Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Action as optimality principle. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them the three dimensions show themselves at once: time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and the motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We are in Episode 8, the pure abstract language. We are still in Book 8.5, Abstract Semantics, where we explore how meaning arises inside the language of phi before we attach it to any particular physical universe. In the last parts, we saw that the language of phi is not just a pile of symbols. It has an internal web of meaning. It has three fundamental ways of projecting itself as time, space, and motion. And it has a way to measure the strength of its own changes using quadratic forms as intensities. So far, everything we have done has been descriptive. We have asked, what patterns are allowed? How can they be combined? How intense are they? Today, we take a different step. We ask, among all the stories that phi could tell, which ones does it actually choose to tell? In other words, once the language has a grammar and a way of measuring intensity, does it remain neutral or does it develop preferences? The central idea of this part is very simple and very deep. The language behaves as if it prefers certain histories over others. It acts as if there is a built-in sense of elegance, economy, or optimality in the way patterns unfold. This sense of preference is what we call the action as an optimality principle. To approach this gently, imagine that language itself could feel embarrassment. There are sentences that are technically correct but clumsy, repetitive, or wasteful. And there are sentences that say the same thing with fewer words, cleaner structure, and better rhythm. When you listen to a great speaker or read a beautiful paragraph, you can feel that some deeper principle of economy is at work. It is not only correct, it is right in a more subtle way. The same intuition appears in countless parts of life. When you walk from one place to another, you do not usually wander in random loops. You naturally choose something close to the shortest or easiest path. When an artisan carves wood, they do not make 10 unnecessary cuts. They find a smooth, flowing motion that gives the desired shape with minimal waste. Again and again, we see the same pattern. Where there are many possible ways to reach an outcome, the systems we see around us often follow ways that look efficient or balanced. The action principle is the abstract version of this idea inside the holophase language. It says, in effect, given many possible ways that phi could change between two states, the patterns that actually occur are those that extremize a certain global score. This global score is what we call the action, and we write it as S of phi, S phi. This score is not attached to a single point. It is attached to a whole story. You can think of phi as the summary judgment of an invisible reviewer who has watched the entire movie of how phi unfolded over a region. The reviewer does not care about one isolated frame. They care about the whole arc, where it started, how it moved, where it finished, and how intense the motion was along the way. How do we build such a score from the tools we already have? We already know how to describe local change through derivatives such as omega, k, and v. We already know how to measure the intensity of those changes through quadratic forms like omega squared, k squared, and v squared. The next natural step is to add these intensities up along the entire history. This is where integration enters the story. We define a quantity called the Lagrangian density, which you can think of as a local score at each point in the story. It is usually built from derivatives of phi and their quadratic combinations. Then we integrate this density over the region of interest, across the relevant times and spaces, to obtain one number, S phi. That number tells us how costly, how effortful, or how elegant a given configuration of phi is according to the rules of the language. The action principle, then, says something very simple. Out of all the nearby possible histories that agree on their starting and ending points, the history that phi actually follows is one that makes this score stationary. Stationary means that if you nudge the history a little bit, if you imagine small alternative stories that begin and end the same way, the value of S phi does not change to first order. It is at a kind of semantic balance point. Sometimes this stationary point is a minimum, like the shortest path between two locations. Sometimes it can be a maximum or a saddle point. The key idea is not least in the everyday sense. The key idea is extremal in the precise sense. The variation of S vanishes. The language has chosen a story that is an extremum of its own internal score. Let us bring this down to a friendly picture. Think of a stretched rubber band pinned at two ends. It could, in principle, lie in an infinite number of shapes between those pins. You could imagine bending it into wild waves, tight zigzags, or elegant arcs. But if you let it relax, it settles into a very particular curve. It chooses the shape that minimizes its elastic energy. That chosen shape makes a certain action score as small as possible under the constraints. In our metaphor, the rubber band's configuration is like a small fragment of phi. The different possible shapes between the pins are like different possible histories. The elastic energy is like a local intensity built from derivatives of deformation. Integrating that intensity along the band gives you an action. The shape you actually see is the one that extremizes this action. The band is not thinking, but the physics of its material obeys an optimality principle that can be written in the language of action. The Holophase picture generalizes this idea. Wherever we have a field that can change according to local rules, we can often describe its real behavior as an extremization of a suitable action built from its derivatives. The deeper claim of this part is that, at the abstract level, the language of phi is naturally organized to support exactly this kind of description. It is built to talk about possible stories and then single out special ones using a global score. The three projections inside the action. Now we must connect this back to our three projections: sequence, coexistence, and transformation. When we build an action, we are really combining temporal intensity, spatial intensity, and motional intensity into one unified functional. From the sequence perspective, the action measures how the rhythm of change is distributed over time. A wildly fluctuating history, where omega is large and erratic, will generally give a larger temporal contribution to the action than a smooth history where omega changes more gently. From this viewpoint, the chosen history is the one whose rhythm is as smooth as possible while still obeying all the other constraints. From the coexistence perspective, the action measures how sharp and complex the spatial patterns are. A field that contorts itself into highly twisted shapes with large gradients and curvatures will give a larger spatial contribution than one that arranges itself more smoothly. From this viewpoint, the chosen configuration is the one that avoids unnecessary spatial violence. From the transformation perspective, the action measures how intense the motion is, how fast patterns move, how abruptly they accelerate, how much they twist as they go. A history where structures jerk and lurch produces more motional intensity than one where they glide along more steadily. From this viewpoint, the chosen story is one in which motion ties time and space together as simply as the situation allows. The full action as phi balances all three. It does not only minimize temporal roughness or spatial sharpness or motional violence in isolation. It weighs them together, according to rules encoded in the Lagrangian. The resulting compromise is the story that the Holophase language picks out as its preferred way of unfolding. From action to equations of motion. At this point, you might reasonably ask, Is this just an aesthetic story, or does it have teeth? The answer is that it has very sharp teeth. When we treat S phi as a functional and ask which phi makes it stationary, we obtain a precise set of equations, the Euler-Lagrange equations. These are the equations of motion for the field. In standard physics, these equations reproduce Newton's laws for particles, Maxwell's equations for electromagnetism, versions of Einstein's field equations for gravity, and the field equations of quantum theory in an appropriate language. In the Holophase program, they become the concrete way that the abstract preference of the language shows up as real dynamics. Because this series is for listeners and not for a chalkboard, we do not need to follow the algebra. What matters is the story. The same language that can describe changes and measure their intensities can also, by integrating those intensities into a global score, generate rules that say which changes will actually happen. Description and selection are two sides of the same internal semantic coin. A closer feel for the principle. To feel the structure of the action principle a bit more clearly, imagine a simple story about a point moving along a line. At the beginning of the story, its position is fixed. It starts at place A at time t1. At the end of the story, it must be at place B at time t2. Within those boundary conditions, there are infinitely many possible ways to travel. It could sprint, stop, go backwards, pause, then rush at the end. It could move steadily. It could move in sudden jumps and rests. In the traditional formulation of mechanics, we build an action by assigning at each moment a local score, usually something like kinetic intensity minus potential intensity, and then adding this score up over the whole time interval. A path that involves wild accelerations and large wasted motions gives a large value of S. A path that is smooth, with kinetic and potential intensities trading off in a balanced way, gives a smaller or otherwise extremal value of S. When we do the maths, the path that extremizes S turns out to be exactly the familiar path that obeys Newton's second law. The abstract optimization rule and the usual force-based description are two ways of telling the same story. In the Holophase viewpoint, we push this idea back one level. Instead of thinking of particles moving in a background, we think of phi evolving and carrying with it patterns that can later be interpreted as particles, waves, or fields. The action is no longer just an integral of kinetic minus potential for a point. It is an integral over regions of spacetime of expressions built from the derivatives of phi itself. Yet the structure is recognizably the same. There is still a local score. There is still a sum over the whole history. And there is still an extremization that picks out the realized configuration. It is important to avoid a common confusion here. When we say the system chooses the path of least action, it is tempting to imagine some conscious agent looking ahead and testing all paths. That is not what is meant. The language of choice and preference is a metaphor for a much quieter mathematical fact, that the actual path satisfies equations that are equivalent to the condition that the action is stationary under small variations. No foreknowledge or decision-making is required. The path does not need to know its future. It only needs to satisfy local equations that happen, when integrated, to correspond to an extremum of S. Another way to see this is to think about how soap films form. When you dip a wireframe into soapy water, the film that appears almost instantly is the one with minimal area. But the film has not had time to explore all possible shapes and compare them. Instead, local surface tension forces act everywhere at once, pulling the film into a configuration where those forces balance. The resulting equilibrium also happens to be the minimal surface. The global optimality arises as a side effect of local balancing. The action principle works in the same way. Local equations, enforced everywhere, give rise to a global extremum. This perspective also helps us see why the action principle is such a powerful organizing idea. When we specify an action, we are not just writing down a single equation. We are encoding a complete set of possible histories and a rule for selecting among them. In technical language, specifying S phi determines both the field equations and the conserved quantities that arise from symmetries. In the semantic language we have been developing, Specifying S phi is like specifying both the allowed stories and the criteria by which the language ranks them. Symmetry, conservation, and fairness. Here, the connection to symmetry is particularly beautiful. In many physical theories, if the action is unchanged under a continuous transformation, such as shifting time by a constant amount, shifting space, or rotating the system, there is an associated quantity that is conserved along the extremal histories. Time shift symmetry leads to conservation of energy. Space shift symmetry leads to conservation of momentum. Rotational symmetry leads to conservation of angular momentum, and so on. This is the content of Noether's theorem. In the holophase narrative, this becomes: when the internal score S phi does not care about a certain kind of relabeling or reorientation of stories, there is a corresponding invariant intensity that flows through those stories. The deep connection between symmetry and conservation is no longer a surprise. It is a reflection of how a self-consistent language must behave when its preferences are themselves symmetric. You can think of this as a kind of ethical code of the language. If phi's action treats all times equally, then there is a conserved notion of temporal intensity we experience as energy. If it treats all locations equally, there is a conserved spatial intensity we experience as momentum. The very fairness of the action score under certain transformations guarantees that some aspects of intensity cannot simply appear or disappear. They can only move around. Let us bring the three projections back into this picture one more time, from a slightly different angle. Suppose we have fixed an action S phi. When we look through the time-like projection, the extremization of S appears as equations that relate accelerations to gradients of some potential. When we look through the space-like projection, the same extremization appears as equations about how patterns must curve or spread to keep certain intensities balanced. When we look through the motion-like projection, it appears as rules about how trajectories must bend and twist to transport those intensities from place to place. The unity behind these different views is the action itself. It is the one score they all agree on, each reading it in their own grammar. This is another instance of the tri-unity. Time, space, and motion are not only three ways of viewing phi, but also three ways of viewing the same optimality principle. You can also sense the presence of action whenever you meet a principle in physics that speaks in terms of least something or extremal something. Least time for light, least energy for stable configurations, least bending for elastic structures, least surprise in some formulations of statistical mechanics. All of these can often be recast as statements about an underlying action. The Holophase framework gathers them into one family and says, this is how a language behaves when it has learned to minimize internal tension across its own dimensions. Falsifiability. Could the principle fail? This brings us naturally to falsifiability. The Holophase framework, when it leans on the action principle, is making a bold claim that the evolution of real systems in nature can be described as the extremization of an action built from holophase-type fields and their derivatives. This does not mean that every tiny detail is exactly optimal in the everyday sense. Noise, imperfections, and local disturbances are always present. But it does mean that at the level of the underlying equations, there is an optimization structure. How would we test this? In practice, we look at real systems, write down candidate actions, and derive the implied equations. If those equations consistently predict observations across many regimes, the principle passes another test. This is what has happened historically. The principle of least action and its generalizations keep reappearing at the heart of our most successful theories. But it is possible in principle for the idea to fail. Imagine we discover the domain of phenomena where no action principle could capture the observed regularities, not even approximately. Suppose, for example, that for some class of processes, the path taken between two states systematically violated every attempt at extremization. No matter how we built S phi from local intensities and derivatives, the real world's behavior would lie away from the predicted extremal path. If such a robust counterexample appeared, we would have to admit that, at least in that domain, the language of phi cannot summarize dynamics through an action. This possibility does not weaken the beauty of the principle, it strengthens its scientific status. By framing our deepest intuitions as explicit claims about action, we make it possible to confront them with reality, and if needed, to revise them. Everyday analogies of optimality. To bring the concept even closer to your everyday life, let us explore a few intuitive analogies. These are analogies only, not literal physics, but they make the flavor of optimality concrete. Think of a person planning a journey across a city. They have many possible routes, many modes of transport, many timings. In their mind, they are balancing several costs: time, money, comfort, safety. Without writing any equations, they are implicitly assigning scores to different itineraries. The route they actually take is usually one that is close to optimal for their internal action. Not too long, not too expensive, not too stressful. Change the weights in their internal score, and the chosen path changes. Or consider how water flows down a mountain. It could, in principle, dribble in every direction, but gravity and friction combine to guide it into streams and rivers that follow certain valleys. Those river courses can be seen as solutions to an optimization problem. Minimize the total effort of flowing downhill subject to the shape of the terrain. Over long times, the water even reshapes the terrain itself to make this flow more efficient, carving channels that embody a kind of geological action principle. Or think of a musician improvising. Within the rules of harmony and rhythm, there are countless notes they could choose. A random choice would sound chaotic. Instead, they choose phrases that balance novelty and coherence. They are extremizing an internal action that scores each possible phrase according to tension, resolution, and aesthetic continuity. The solo they actually play is the optimal path through their internal space of possibilities, given their taste and the context. In each of these cases, a system with many possible behaviors ends up following a path that can be understood as an extremum of some score. The Holophase language takes this pattern and makes it explicit and universal at the abstract level. Before we close, let us practice a simple recognition skill. Whenever you see something unfold in a way that feels just right, a falling cat twisting in midair to land on its feet, a vine curling around a support, a bridge arched in a way that looks both strong and graceful, pause and ask, could this be the expression of an underlying action principle? Could there be a hidden score built from intensities of change that this system is extremizing? You do not need to know the formula. The point is to train your eye to see optimality not as a miracle, but as a natural consequence of a language that has learned to be economical. The more you do this, the more the world starts to look like a tapestry of optimal stories, each one a compromise between many competing intensities. Zooming out, where this fits in the master tree. Finally, we zoom out to where this part fits in our climb up the Holophase master tree of language. We began this episode with the pure structure of phi, then built its grammar, then its topology, then its internal semantics, then its threefold projection, and then its measures of intensity. With the action as optimality principle, we have reached the point where the language can not only describe and measure, but also choose. It has a built-in sense of which histories are most natural according to its own internal rules. Remember, despite all of this richness, there is still only one field, phi, and its derivatives. We have not added mysterious new substances. We have only uncovered deeper layers of organization in how phi speaks. The action is the way phi judges its own stories, selecting those paths where its rhythmic, spatial, and motional intensities are woven together in the most balanced way. In the next part, we will turn to the idea of spectral modes, how the Holophase language can decompose its stories into basic tones and patterns, the way music can be decomposed into pure notes. This will complete our tour of the pure abstract language and prepare us to descend from the Platonic level of phi back into the concrete worlds of physics. For now, as you move through your own life, notice the paths you take, the choices you make, and the ways in which you too are constantly extremizing small internal action principles. Saving time, conserving energy, protecting relationships, seeking beauty. In this sense, you are not separate from phi's optimization. You are one of its voices. Salam and peace be upon you.